Hi, everybody. I am Tammy Murphy. I'm with Physicians for Social Responsibility in Pennsylvania. I'm the advocacy director for the organization. And if you would like to, while we're getting started, you can put your name and any information about where you are from or anything that you want to share with us in the chat. We are going to have two presentations. We're going to have a very brief presentation from University of Chicago to kind of give us an overview. And then we're going to jump right into our main presentation with Dr. Ketterer. So first, thank you very much for joining us. We're very excited to have everybody here. And thank Halt the Harm for helping us operate this webinar. And I am going to introduce you now to AC Staubel from Halt the Harm.
Hi, everybody. I'm AC. I'm a community organizer at the Halt the Harm Network. And if you haven't heard of us before, we would love to invite you to the network. We're a network that connects leaders and supporters in the movement to halt the harms of fracking and other environmental issues. And our goal is to really serve leaders and community activists like you all who are advocating for the changes and who also just want to be aware of the issues around fracking and other environmental concerns. And if you're interested in joining the network, I'll drop the link right now in the chat and you can check it out. It's totally free to join and you'll hopefully make some connections with other leaders in this movement. So thanks again for being here. And I'll also, if it's okay, I'll introduce Trevor quickly. Trevor Spreadbury is going to give us a brief presentation. He's from the University of Chicago, and he'll tell you a little bit more about himself.
Thanks, AC. Yeah, I'm a software engineer at the Data Science Institute at the University of Chicago, and most of my work focuses on working with nonprofits in the areas of food, agriculture, human rights, and energy. And I've been working with Tammy for a few months now, looking through some data from a study that Physicians for Social Responsibility conducted and creating some visualizations on those results. So I'm going to share those now. Second. All right. So this first visualization is just a summary of some of the results that they obtained. So at the bottom here, we're looking at all the samples that Physicians for Social Responsibility took across the state of Pennsylvania. These are anonymized, so we're just changing the names to be sample with a number, since some of these were personal residences. And for each one, we're showing the detected picocuries per gram of radium-226 in red and radium-228 in orange. As we see at the bottom, there's a dotted line displaying the natural baseline that one might expect anywhere of radium-226 or 228, which is around 1 picocurie per gram. As we see, a lot of the samples are close to the expected baseline, though some exceed it by quite a bit. These study is just looking at a few locations across the state, so you can't draw too strong of conclusions from it. To continue on, we sort of have, all right, so to continue, we have sort of the average amount of picocuries per gram of each isotope, radium-226 in blue this time and 228 in green, for each type of site that the sample was taken from. So we have samples that were taken from transportation sites, community sites, residences, compressors, landfills, processing sites, rail yards, and well pads. And we see here that there's, on average, a bit elevated levels of radium-226 by the compressor stations and the processing plants, and a little bit on the community ones. though the amount of samples in each one of these types is small enough that we can't draw conclusions and say something like it's more likely for there to be a higher level of radium-226 by a processing plant. At this point, the strongest conclusion we could probably draw is that more data is needed and more research is needed. So before I jump into a map of where these locations were taken from, I just want to preface it with this map from Frac Tracker Alliance. This is available on fractracker.org. And this is just a map of all oil and gas wells in Pennsylvania. As you see, the number is sort of overwhelming, so it would kind of drown out anything else in the map. So I've excluded it from the next map. But I just wanted to not give a false impression of the amount of oil and gas wells in the state. So this is the map with just the locations of samples that were taken by Physicians for Social Responsibility. And it's coded by the summit amount of radium-226 and 228. So most of the samples you can see are in the southwest of the state, and there's a few in the southeast. And this is that same map, but this is just adding in a lot more information on different oil and gas sites. So we have in blue, we have pipeline routes, we have some well sites, compressor stations, locations that have accepted solid and liquid fracking waste since 2008, and disposal wells. These are again all thanks to Frac Tracker. And if we zoom in to the highest concentration area where samples were taken in the southwest, we can see an approximate idea of where these samples were and sort of what types of sites they were near. Yeah, and to finish up, I just want to show the initial chart again, as you might have some more context now for what these numbers might mean. I will hand it back off, and Dr. Ketterer will give a lot more context as to what exactly this means and some other studies that have been conducted.
Okay. Trevor, thank you so much for this presentation. We really wanted to give people an overview of the study, and as I should have explained in the very beginning, we did this study with Wayne State University and Justin Noble. So we kind of pulled the group together, and with Dr. Haley too from UPMC, and we had local guides, Lois Bauer Bjornson in Southwest Pennsylvania and Krista Giulio in Southeastern Pennsylvania. So they toured us through the state. We mostly stayed in the southern part of the state. We took 1 or 2 samples from the northern area later and added it to the study. The study was done quite a while ago. There was a delay because there was a large flood in Detroit, and the Wayne State University lab, a lot of equipment needed to be replaced. So most of the samples survived the flood, but it took us a very long time to kind of get through it. And the research itself is very technical. So we worked with the Nuclear Information Resource Service. Our friends over there introduced us to Dr. Ketterer, and he basically took a look at the like an objective look without talking to the researchers from Wayne State University, just to keep it objective and see what he saw in the data and kind of break that down so that people can understand it. We're going to have a probably pretty solid question and answer session, because I know a lot of the stuff is really technical. So if you have questions for Trevor, or you have questions later for Dr. Ketterer, if you can put them in the chat. AC and I will be watching that and trying to keep track of all the questions and answers, and we will try to get to everybody. If there's something that we can't get to, we will try to answer you later. And then just to be really clear with everybody, this is a very broad overview of the study, and what we intend to do throughout this year is go into each community where we did the testing, and we're going to have 5 town halls. So we're going to be coming there to the areas and doing in person. We'll sort of hybrid. We'll have a space where some of it is live streamed, at least the informational part will be live streamed. And then in the second half, we're going to be taking time to answer people's questions and see how people are feeling. And we'll bring some other data related to air quality. So that is set up for the rest of the year, and that information will be shared with community through community organizers in the places where we did the testing. Our first one will be March 29th, and that's the sort of Chester County, Delaware County area. And the event will be in Chester County. So we have more details about those town halls for folks as the year carries on. For now, let's take advantage of the fact that we have Dr. Ketterer right here with us. And Dr. Ketterer is with, he's Professor Emeritus with University of Northern Arizona. And he can tell us all about what he thought about the data.
Thank you very much, Tammy, and I want to thank PSR Pennsylvania and Tanya Verkaitis, as well as NEARS, for making the connection here and bringing me on board. I'm going to show, let's see, there. I'm going to show some slides here. My background is in chemistry and analytical and environmental chemistry. And for the last 25 years, I've been specializing in studying radioactivity in the environment, both of the naturally occurring variety as well as other stuff that is consists of synthetic radioisotopes. And so the oil and gas related radioactivity, sometimes called NORM, or naturally occurring radioactive material, falls into this category of stuff that I'm interested in. And so here is an overview of what I did. I looked at the Wayne State University data set. I'm well acquainted with Dr. Mark Bhaskaran, and as Tammy said, I did not communicate at all with him regarding this study. I just took the data that was given me at face value. So I'm going to discuss what I'm seeing in the Wayne State University data set. And then as I got into this a little bit more, my mission quickly seemed to be getting broader and broader, and it seemed appropriate to get broader. I wanted to address the question of, well, should we worry about this issue of naturally occurring radioactive material in association with oil and gas developments in Pennsylvania? And then going even broader than that, besides the naturally occurring radioactive materials, should we consider some additional environmental hazards? The oil and gas development is a very complex thing, and there are multiple pathways by which contaminants can impact humans. So in the Wayne State data set, Bhaskaran and co-workers collected a series of soil and sediment samples near oil and gas installations from residential properties as well. In their work, in their laboratory work, they determined the activities of several radioisotopes. They are expressed in picocuries per gram. In case you're wondering what a picocurie is a measure of how much radioactivity you have. It actually corresponds to however much quantity of that radioisotope will generate 0.037 decompositions per second. So it's a relatively small amount. Pico is 1 part per 10 to the 12th, or 1 part per trillionth. And a curie is a relatively large amount. So the concentrations or activities that we're finding are actually quite small, measured in picocuries per gram. And in Bhaskaran's work, they also calculated doses to humans for people who would be spending time near these installations. So EPA, US EPA, has soil remediation guidelines, and they are saying that on the order of 5 picocuries per gram of radium-226 and or radium-228 is considered to be a soil remediation guide and or health-based standard. There's some ambiguity. I actually, long time ago, used to work for EPA, and even saying that, I find it difficult sometimes to interpret what regulations are saying. Nevertheless, 5 picocuries per gram, which Trevor mentioned also, is a guideline on, this is a level where we start to have concern So one of the questions here in this work is to try to discriminate what is coming from the geochemical baseline, or some people can use the word background. What we mean is what came from nature and has not been disturbed in any way versus oil and gas related. These radioisotopes also came from nature, but they have been liberated and disseminated and spread around as a result of human activities. So we expect about 1 picocurie per gram for all the isotopes in the uranium-238 and thorium-232 decay series. So radium-226 is in the 238 uranium series, and radium-228 is in this thorium-232 series. Now, if we consider the natural Earth's crust and we start adding in stuff from the Marcellus oil and gas, wastewater, for example, what you see are two things. One is there will be an increase in the activities of both isotopes, and levels of hundreds or even thousands of picocuries per gram are possible and have been encountered in oil and gas settings. But secondly, the ratio between the 226 and the 228 activity, or the activity ratio, is generally significantly higher than 1 for stuff coming from the Marcellus shale. This ratio is somewhere in the order of 4 to 5. So we can think of it as that is a fingerprint. So two things will happen. There'll be an increase in how much radium-226 and 228 you have, as well as there will be a relative increase in this 226-228 ratio. The 226-228 ratio is not anything that I invented. This is a paper from Lauer and co-workers, Environmental Science and Technology. And you can see here, they're reporting data from stream sediments near where some of these wastewaters are disposed of in streams. Just to confuse audiences, there's a different scale used here. It is becquerels per kilogram. 37 becquerels per kilogram equals 1 picocurie per gram. So I've drawn in the red line as to what the geochemical baseline should be. And you can see that when there's oil and gas effect, the concentrations of both isotopes go up, and the radium-226 is higher than the radium-228. If you compare the pinkish to the greenish box in those plots. So I looked at the Bhaskaran data set, and I am showing you copies of the data tables that I was looking at. I removed all the sample identifiers. And so this is essentially the raw data that I have been evaluating. And to point out a couple of my main findings for the Bhaskaran soil and sediment samples, there was one residential area that was sampled where elevated concentrations of lead-210 and polonium-210 were found. Those two isotopes are actually what are called radon daughters. And it is plausible here that this residential drinking water well is being affected by radon-222, and the radon is being liberated from oil and gas. So it's possible, I would put this in the category of possible that there is some influence of oil and gas on this well. This is actually sediments from the inline water filter. The second thing that I found was that there was one particular compressor station where there was slightly elevated radium-226 activities. They did not reach 5 picocuries per gram, but they were slightly elevated. And also the radium-226 over radium-228 activity ratio seemed to be a little bit elevated. So I would also put this in a category of there's possibly some impact here, and that might come from insoluble solids called scale, which I will say a little bit more about later. However, in looking at the Bhaskaran data set, I did not find any instances where the radium-226 or the summed activity exceeded 5 picocuries per gram. Instead, there's a few where it's close to that, but not exceeding 5. So EPA, US EPA would say that there is no problem here, nothing to remediate. Here's an example of, this is the data from the compressor station, and I'm highlighting here how the radium concentrate 226 concentrations are slightly elevated, and they're also higher than the 228 concentration. So I'll put this in the possible influence of oil and gas in this location. And so how bad can things be? Well, activities can be tens or hundreds of times the levels that are seen in the Wayne State University data set. This is again from the Lauer paper that I mentioned earlier. And they were actually sampling sediments from streams where the oil and gas produced water or wastewater, whichever you wish to call it, where that was being discharged into the streams, and stream sediments from these areas exhibited very, very high activities of both 226 and 228. But again, you can see that the 226 is higher than the 228. So to summarize, what I can say from the Bhaskaran data set is it appears there's some oil and gas impacts at one private water well, maybe due to radon from the oil and gas entering the shallow aquifer, and in the soil collected from this compressor station. However, we didn't see anything above this EPA remediation guideline. Nevertheless, I want to leave you with the thought that absence of evidence is not the same thing as evidence of absence. So we have not really found any egregious conditions here of extreme contamination. There's some hints of that, but it doesn't mean that we can pronounce the whole state and every location in the whole state to be clean. Instead, I think it is highly prudent to conduct additional radionuclide testing at other locations, because I think if you look enough, then one will find it. So broadening from the Bhaskaran study into what other things should we be concerned about with respect to oil and gas and naturally occurring radioactivity. The brine produced water, it's called produced water, or sometimes it's called processed water. But the brines that are extracted along with the oil and gas often have extremely high concentrations of radium. So this is a paper there. The authors were focusing mostly on the Bakken in North Dakota, but the same situation exists in most of these shale formations. So if you look at the bar in red down at the bottom, picocuries per liter concentrations of the hundreds and thousands are seen in different produced water brine samples. So many of these exceed this 5 picocuries per liter, which is a drinking water standard for US EPA. So this is a picture that I took from the website shown below. There's some tanks with some of this brine water. What do we do with this stuff? This is really kind of a problem. One of the, I would say, less enlightened things that we've done with this is to spread it around on roads. So here's a paper that looked at that and describes some of the potential pathways to humans and to animals and its effect on the environment. And this is evidently a fairly widespread practice in your neighboring state of Ohio. This product called Aqua Salina was sold and used to spread on roads. It says right on the label, it's safe for the environment and pets, but samples of this have tested to be in the thousands of picocuries per liter. So this is basically liquid radium solution that, yes, it will function as an electrolyte and will lower the freezing point of water, but you're dispersing this radioactivity everywhere. And then after it dries out, you get this aerosol. And so people will be breathing it. This is just not a good idea in my humble opinion. Another thing that occurs in these installations is that there's a buildup of what's called scale. So this is a solid material that forms on the insides of pipes and valves and fittings on the ground and so on. There's a change in chemical conditions when the water is brought from depths up to the surface, and the chemical term that is used is precipitation. So precipitates or solids form out of this briny solution brought up from the depths, and that forms this scale. And that scale often contains very, very high levels of radium isotopes. So one of the things that the industry does with it is to try to filter it out and remove the scale from the brine processed water. And there's actually a case that is from Martins Ferry, Ohio, where this facility, Austin Master Services, was handling these filter materials and contaminated their building and the surroundings, and probably exposed some of their employees. So it really generates a question: what exactly should we do with this scale? There's really no regulatory solution to this at this point in time, so it gets tossed into landfills and pretty much anywhere and everywhere. Another hazard associated with oil and gas is radon gas, which I mentioned earlier in the context of the one set of samples. The paper that's shown there on the right-hand side is saying that one of the predictors of indoor radon concentrations in Pennsylvania is oil and gas development. So being close to oil and gas is one of the predictors of high radon concentration. So there's an association there. So there are definitely some significant things to think about with respect to radioactivity hazards of oil and gas development, but broadening the scope even further, what else should we be concerned with? There's a lot of things. This is a complex multimedia type of pollution problem. There's volatile organic compounds released into the atmosphere, and these are at ground level or close to ground level, and in many cases they are near residences. I live in Colorado, north of Denver, and I'm close to an area where a lot of this unconventional oil and gas development is taking place. And there are times where you drive by some of these installations on a calm evening and you can just smell the hydrocarbons coming out. So volatile organic compounds going into the atmosphere is a problem. And it also generates an air quality problem. In fact, this area north of Denver where I live has problems with ozone non-attainment. And a lot of that is coming from ozone precursors such as hydrocarbons. Well, here's your source of hydrocarbons. So there's also, besides the radium in the water, there's all sorts of other toxic elements, cadmium and arsenic and so on. There's peer-reviewed studies that have looked at these. Also, it's been the practice of the oil and gas producers to use all sorts of additives to their fluids that are used for fracturing in this fracking process, as it's known. And these proprietary or trade secret or undisclosed additives, they become contaminants in the surface water, in the shallow groundwater in the process. water. And then finally, I think this one is on the tip of everybody's minds. In association with oil and gas, we can certainly have road and rail transportation accidents. A lot of the processed condensate, the liquid condensate from oil and gas consists of light hydrocarbons, and it's shipped by rail to refineries. So there's a complex mixture of different things that represent hazards associated with oil and gas development. So here's an example of natural gas being flared off. And if we just let it go into the atmosphere, that would cause one set of problems. If we flare it off, it will produce another set of problems. Here's a recent study that shows that methane concentrations in the atmosphere seem to go up when you are in an area. This is specifically for the Marcellus Shale in an area surrounding Pittsburgh. When you have a high density of oil wells, there is an increase in the methane concentration in the air. And in association with the methane, there are all these other hydrocarbons. So the C1 through C10 volatile organic compounds are referred to there. There's documented cases of hydrocarbons from oil and gas contaminating surface water. These two papers are presenting some evidence towards that. So finally, I want to draw people's attention to another class of compounds that may be found in association with oil and gas, and that's substances that are called by their short name PFAS, or forever chemicals, but that stands for poly and perfluorinated alkyl substances. So these are carbon chains, very similar to, say, the fatty acids that nature makes, but in this case, the hydrogens on the carbon chain have been replaced by fluorine atoms. And it's this carbon-fluorine bond that is making this molecule resistant to biodegradation. So these compounds are very, very stable and resistant to thermal as well as biological degradation. EPA is now considering them to be an emerging contaminant. There is no drinking water standard yet, but 70 nanograms per liter, summed concentration of two specific compounds is the current guidance. So we'll see if this eventually gets promulgated, but meanwhile, people's attention is focused on these substances because in this situation, they are probably also associated with many oil and gas developments. So this is from the New York Times a year and a half ago or so, showing that PFAS compounds were allowed by EPA to be used in fracking mixtures. And here's a shout out to PSR. This is a report that you can look up. There's the web link there. But this report is talking about the association of these forever chemicals, or PFAS substances, with the fluids used in oil and gas. And if you start to do the math on how many pounds were used in each well, and you think about the numbers of wells, and you think about how small 70 nanograms per liter is, a single well and you know, a few thousand gallons of processed water or wastewater from that particular well can contaminate an awful lot with PFAS concentrations well above this 70 nanograms per liter. So concluding what I wanted to say before we go into discussion, that my take-home messages are: the Bhaskaran study has identified a couple of situations of NORM contamination, although other studies have found much more elevated concentrations of radium in certain locations in association with oil and gas. So I think my message here is we need to be looking elsewhere in other places, and to keep looking and to keep looking. It's you know, it's easy to prove that something is dirty, just find the contamination, but to prove something is clean requires a much more exhaustive effort. But besides the naturally occurring radioactivity, proximity to oil and gas is associated with increase in concentrations of methane, radon, and all sorts of hydrocarbons in the air. Shallow groundwater contamination can come from this. And finally, I do want to focus on what else is in the water. When I hear of people that are getting sick that live near these installations, that's the question that arises in my mind. You know, there's a lot of unknown substances that are present that may be associated with health effects. So finally, I'd just like to thank people for their attention, and that concludes my formal remarks. I will stop screen share there.
All right. Thank you so much, Dr. Ketterer. That was really excellent. And I enjoyed your presentation a lot. We now have 63 participants and we have some very robust questions. So I think that if I'm not mistaken, I think that all of the questions at this point are directed to you, Dr. Ketterer.
Okay, so do I go to the chat and start looking at them?
I can read them to you so you don't have
Okay.
to. Okay.
Yeah, that sounds great, AC.
Okay.
Yeah, there also, just to say this too, there are also some folks here. I know that I'm just looking through our participants, we have quite a few knowledgeable people in the attendance. So also, if you want to keep the chat going, and we've got some time still. So if you want to keep that going, I'd really appreciate everybody's contribution.
And we just got one question, then I'll go back to the start. But Mark asks, are your slides available for further study, Dr. Ketterer?
I'm happy to give these slides to PSR PA, and I can send them to Tammy, for instance, or people can contact me directly. I have no problem with publicly releasing my slides.
Awesome. And
That's great. And the recording will be available on our website in a little while, once we get organized afterwards.
awesome.
Okay,
Great.
thanks. Do you want
So-
to take it away, AC?
Sure. Yeah. So our first
Great.
question came from Tim Judson. Could you explain the use of logarithmic scale on the last graphs? So it was early on in the presentation.
Well, logarithmic scales are usually used to display data when you have a very, very large range of concentrations. And it in this particular case, I think is trying to emphasize that the concentrations or activities of radium-226 and 228 are varying quite a lot, as well as are much higher than the baseline. It's easier to show that on a logarithmic scale. And the logarithmic scale, you know, each unit is a power of 10. It's going 1, 10, 100, 1,000, etc. I'm taking the figure directly from the author's figures in the paper, and I think it makes sense to use that kind of scale there.
Excellent. Thank you. And then Terry asked, how much radium can be removed from contaminated stream water? That is, what is the efficacy of filtering radioactive material from surface water?
Well, there certainly are technologies to remove radium 226 and radium 228 from water, to treat it, to make it drinkable. I think the problem comes in when you leave the laboratory scale of treating a few liters or a few gallons here and there to the industrial scale of tens or hundreds of thousands of gallons or liters per day. but there are materials referred to as ion exchange resins, similar to the beads that are used in water softeners, that can be used to remove radium from water. It's a contaminant that can be removed, but then, you know, the downside of that is now you've created a solid waste stream. What do you do? It's sort of like, what do you do with this filter sock where you filtered out the solid particles? I think on a residential scale, if there was, say, a family where their well was tested and it was 15 picocuries per liter of radium, treatment of a few gallons per day for drinking purposes would be feasible. But removing radium at thousands of picocuries per liter from untold thousands or hundreds of thousands of gallons of water is just an impractical undertaking. It really is. I do not have an answer to this one as to what should we do with this stuff.
Right. And then Amy Marsh had a question as well about where the radioactive brine is disposed of in Colorado. Do you know where that goes?
My understanding is I haven't paid a lot of attention to that particular question, but my understanding is that most of it is disposed of in deep injection wells. So essentially, it's, you know, being forced down, pumped down into the bowels of the earth. That's not necessarily a perfect solution. It's been shown, you know, it costs a lot of energy to do that. But the other problem that's associated with it is sometimes deep injection wells have led to lubricating faults, and there's actually an increase in tremors and earthquakes that can come from that. So I'm not sure that that's the greatest answer. Sending it to the publicly owned treatment works, POTW, is not really an answer, and disposing of it in surface waters or just pouring it out onto the ground. You're not going to get rid of radium by any means other than to let it wait long enough for it to decay.
And how long is that?
Well, radium-226 is 1,600 years, something like that is its half-life. 228 is much shorter. I believe it's about 5 years. But, you know, we're looking at a couple tens of thousands of years, you know, 20 to 40,000 years, it will remain radioactive. So I don't think that, I'm sorry, I'm not the guy that has the answer on what to do with the stuff.
Okay, that's okay. We appreciate what you're doing. And so Amy, who lives in Colorado, is also wondering if there are any studies that you know of, like this one that was done in PA, for Colorado.
I don't know, but now that now that my interest has been piqued a little bit, I think I'm going to find out.
Okay, fantastic. And Amy says thanks in the chat. That was very helpful.
Okay.
Yeah, I can just say that I don't think that there was a study quite like this in Colorado. As far as I know, there really is not a study like this anywhere. We were introduced to the researchers at Wayne State University from Justin Noble, who's been doing a ton of research on this topic. And Justin is here in the webinar, he's present. But we were introduced then, and it kind of was just like the opportunity, they were available, and that is their specialty. Radioactivity is their specialty, and they hadn't really gone into environmental issues, especially not particularly fracking. And then there was, when we were just about to start the study, there was a study from Yale that came out, and they kind of, in doing a different study, they kind of happened upon the fact that they were detecting radioactive emissions coming off of fracking industry sites. So they noticed it. It wasn't what they intended to study. So it was really kind of exciting for us to go into this intentionally. And like I mentioned after Trevor spoke, this is really a very preliminary study. And Trevor and Dr. Ketterer have both pointed out that our results are small. It was a really small scale study. So a lot more needs to be studied, but we did, because things are above our base level, we definitely know, and there are some patterns that we're seeing. We definitely would like to do more studies going forward. And if other states could do it, that would be great. That would be also awesome. So we can move on to the next questions too. Thanks.
Okay, thank you for that. And just one more follow-up from Amy. If you know of any, do you know of any studies that have been done on endocrine damage from fracking in Colorado or maybe otherwhere? Either Michael or Tammy.
No, I'm not familiar with endocrine disruptor studies, but considering the complex mixture of hydrocarbons and all of these additives, I would not be surprised if there was that type of endocrine disruption activity.
Mm-hmm. Thank you. So then PK asks, why is breathing particulates or aerosols with radium attached so dangerous to human health?
Well, I'll qualify my answer by saying I'm not a toxicologist, but in general, if you're breathing in, say, an aerosol that contains elevated concentrations of radium-226, radium-228, those fine particles are going into your lungs, they'll be assimilated, and radium is what is considered to be a bone seeker. It's chemically in the periodic table under calcium, and it has a propensity to accumulate in bone, and human exposure to radium. The radium dial painters is a famous example. Human exposure to radium often leads to bone cancer and different types of leukemias associated with the bone marrow. So inhaling any alpha emitting radioisotope is not a good idea. That's really the way that it can hurt you, is by ingestion or inhalation.
And then how can these folks get away with saying that the de-icer like Aquasalina is safe when it's been studied and proven that it's not safe?
I don't know. I don't really know how somebody can make a claim like that in light of the concentrations of radium being, thousands of times the drinking water standard.
Right.
Not that you would drink it anyway, but it's pointing out that this has got a lot of radium in it, an awful lot of radium in it. I don't know. That would be a question to ask the Attorney General of the state of Ohio. What do they think of that? I think it's it's a very obvious false statement.
Mm-hmm. And then PK also asks if there are any other known brands that have been discovered to have high radium levels or using oil and gas brines like Aquasalina that you know?
I don't know of other brands of stuff that you can go and buy at the hardware store. I've never seen it in any hardware store that I've been in. Ace Hardware in Longmont, Colorado does not handle any of these products, but there appears to be also significant usage of this, not as a bottled product, but in tanker trucks for road, for anti-dust, for dust suppression activity, as well as for use as a de-icer. They might just load up tanker trucks with it and use it that way. I don't have an answer as to what we should do with these brines, but spreading it on roads is by no means a good idea. You're putting it into places where humans are going to contact it.
Yes. And then PK also asks about the Halliburton loophole. Why is oil and gas industry still exempt from the RCRA standards, cradle to the grave? And are you aware of any legislation or lawsuits which are dealing with changing these exemptions?
Well, it seems to me, and I first became familiar with RCRA back in the late 80s when I worked from 87 to 93 with EPA and became familiar with the hazardous waste regulations. And oil and gas had all sorts of their own little loopholes back at that time. But the more recently created so-called Halliburton loophole just seems to exclude all of these wastes being generated from oil and gas. It excludes them from coming under the purview of RCRA, which RCRA is an acronym for Resource Conservation and Recovery Act, and it's the main set of legislation that deals with disposal of hazardous waste. Certainly, these wastewaters and the scale and things like that, they would by any reasonable definition, they should meet the requirement, the attributes of hazardous waste, but they aren't. I think the answer is that it comes from the political process, and EPA is an agency fundamentally that is a politically oriented agency, even though they are a regulatory agency. I do not know of any efforts or initiatives to change any of that. I think if EPA came along and said, we are going to close the Halliburton loophole, we are going to tightly regulate all of these contaminants from oil and gas, I think the oil and gas industry would say, you've just put us out of business. And it may be that it really isn't possible to generate oil and gas using these unconventional fracking-based methods. We may not be able to generate millions of barrels per day without creating these wastes. And if the true cost was paid by the producers rather than, socialized, I think that the oil and gas produced in this way would probably be much, much more expensive.
Mm-hmm. Yeah. So if there's radioactivity in the gases that they're flaring, will radioactivity actually be burned off, or will it end up as fallout on the surrounding community?
I think one of the things I came across was that some natural gas that's produced from shales contains radon. And the answer to that is it's got to go somewhere. So gas is being vented, being flared off. There's quite likely radon contained in those gases. Radon decays quickly. It has a short half-life of 4 days approximately, but it forms what are called radon daughters. So it forms new isotopes that are themselves radioactive and will continue to be radioactive for some decades. Yes, there definitely is a pathway for radon to be liberated from the shale formations, to go into the water, to come out with the gas, and to be liberated at the Earth's surface. And for humans to come into contact with it, there certainly exist those pathways.
Okay. And I also just saw in the chat that PK says, thank you, Dr. Ketterer, regarding your last comment about the EPA. People need to think about that. It's kind of scary.
And I say that from the perspective of somebody that worked there.
Mm-hmm. Yes. So next question is from Rice. In Ohio, the state is assuming natural background of about 2 PCI per gram, is that how you say that, of radium-226 and 288. For landfilling, there is no problem as long as the waste coming in is not more than 5 PCI per gram combined radiums coming in. So of course there are no basic screening practices that can measure that low of only radiums on the fly. Are you concerned about the landfilling of shale drilling wastes?
I think it's something to definitely be concerned about. Just to put these wastes in the sanitary landfill leaves leaves the possibility of future impacts on drinking water. You know, a better solution might be to put these solid wastes in some type of a lined landfill, what might be considered to be a hazardous waste landfill, but of course that's much more expensive. But you're right, it isn't so easy to, short of doing laboratory testing, it isn't so easy to, you know, hold a counter up to the material unless it's much higher than 5 picocuries per gram. You're not going to notice with some kind of a handheld screening device, a gamma counter, you're not going to notice that it's above 5 if it's 15 or 20. If it's 15,000, it'll be giving off enough gammas that it would be noted, yes. But I'm seeing problems anywhere we look at how to dispose of the brines and the scales and so forth.
Mm-hmm. Yeah, that makes sense. So our next question, these are great questions, everybody. Thank you so much. Next question is from Mike Martin. With the large amounts of PFAS forever chemicals being used in fracking, does the contamination of drinking water occur quickly or is it delayed? And is it possible that we will see increasing contamination of drinking water for years to come, even if the use of forever chemicals is stopped?
I think that as soon as the material is brought to the surface and the water is, say, disposed of in the surface environment, it you know, it's the PFAS compounds are already present in the water in dissolved form, and there you already have it, and it is immediately a problem. So, for example, in the paper that was examining these contaminated sediments in the streams, where they were basically just dumping out the process water directly into surface streams, one would expect that there could be, besides the brines, there could be a mixture of all kinds of additives like PFAS present in that water. And I think to answer the question is it's probably already a problem. It hasn't been looked for extensively in oil and gas areas. I suggested to PSR Pennsylvania that this might be an initiative they might want to undertake. But I think we're looking at a situation where there's a few years of development. These wells are typically very short-lived, followed by a long time of ongoing contamination. When I see the oil and gas developments near where I live in Colorado, which is more or less the last 10 years has witnessed this development. When I look at that, I think 20 years from now, if I'm still around, there'll be lots of work for consultants to study all of the water contamination problems that are the legacy of that oil and gas development.
Thank you. Next question is from Terry. Is radium more readily water soluble than, say, plutonium? Radium-226, radium-228. Chemically, radium is relatively soluble, but it tends to form an insoluble sulfate, and so it can be present in dissolved form, but it can also form a precipitate, such as the scale is probably mostly barium sulfate with radium mixed in it. In general terms, radium is probably more soluble and has a greater propensity to migrate or move chemically in the environment than does plutonium. But radium solubility is controlled under and its ability to move is controlled by the fact that its radium sulfate is relatively insoluble. Okay. And Diane wants to know, do you know the technical basis for the 5 PCI per gram EPA level that they use?
No, I would have to confess that I don't know the basis for coming up with that number. I think it's a combination of the radium having a propensity to interact with vertebrates and to go into the skeleton. I think the action level or the remediation guideline for radium is significantly lower than other isotopes, like, for example, uranium. I believe 15 and 30 picocuries per gram have been used as remediation guidelines, and radium is 5. It's probably acknowledging the fact that this is a very dangerous isotope from the standpoint of being a bone seeker. But I don't really know. I haven't looked at, what the what is the basis for the health-based guideline.
Thank you.
I'll accept it as a fact that 5 picocuries per gram radium should raise our eyebrows and we should stay away from it.
Yeah. And this is a question from Yvonne, which I'm a little scared of the answer. Is radioactivity risk of brine in finished and plugged frac wells likely to continue after the expected lifespan of the well plug?
I think that the possibility always exists for when you have deep wells, and the brines are down thousands of feet where the oil and gas is in 7,000 to 15,000 feet below the Earth's surface is my understanding of where they are. I think one of the risks that could be associated with plugged wells is cracks in the casings or fissures that are associated with the drilling and the fracking itself, generating pathways for that contaminated stuff to enter shallow aquifers. So these formations where the brines are and where the fracking is being done are way below the depths of drinking water wells, but nothing is perfect, and I'm certain there are documented cases where that has happened. It's probably a better situation to have it plugged than to leave it abandoned, but I don't think that means the risk is zero.
Okay, thanks. Question from Terry: does alpha radiation, like RA, penetrate the metal walls of tanker trucks?
No, alpha radiation, which is the nucleus spitting out a small chunk of itself, it's actually a helium atom, is not very penetrating at all. A simple piece of paper or a few layers of epidermis will block an alpha particle. It won't come out of a tanker truck. However, some of these isotopes in this brew will also be emitting beta and gamma radiation. In fact, radium-228 is a beta emitter, and radium-226 also emits low energy gamma rays. So those can certainly come out of the penetrate through the steel and be detectable outside of the tanker truck. But the alpha particles themselves are contained pretty well with any type of container.
Cool. That's good. So I have 3 other questions from the chat, but PK asked to ask you something just in person because it's too much to type. So here we go, PK.
Hi, Dr. Ketterer. Thank you so much for everything. My question is about dosimeters. So I am a watchdog and I go out into areas, and thank you, Justin Noble, by the way, for giving me an awesome Geiger counter suggestion, which we purchased and I use. My question is, how do you think, like, for people who are maybe like for me, who goes out there, or anybody maybe living in an area, how a dosimeter could possibly be helpful for them just to know the accumulation? that they're being exposed to. I'm not sure if that's applicable. Is that the word I'm trying to say? Yes. And so I don't know if you could, expand on that or just comment to that. Is it useful? Thank you.
I think this is a highly useful idea. In general, I believe that when citizens are confronted with some type of an environmental hazard, a pervasive, large problem like this, don't count on the polluter to help you. And sadly, I'd also have to say, don't count on the responsible regulatory agencies to help you. I think that people need to help themselves and take charge of it at a community level. I mean, one of the things I was thinking about after looking at Trevor's slides of how extensive this is in Pennsylvania, it seems like every township ought to have some type of radiation detection equipment, a good handheld Geiger counter that will count gammas and could be, brought near wellheads wherever you see some, whitish precipitate, go there and count it. And if it's clicking a lot more than it did when you did a background count, then it says don't go near that area. I think it's a wonderful tool for people to have. I think you could probably detect some of the most extreme situations of contamination, but if the levels are only slightly elevated, you may miss things.
Awesome. Thanks, PK. So Mark asks, is the measurement that has calculated the total brine being wasted from one well per day? Or is there a measurement that has calculated the total brine being wasted from one well per day? So there's a lot of variables in well production, but it would be useful to understand the scale of the waste being generated by a single well.
I don't know what the numbers would be, but having personally seen the scale of some of these developments, the tanks are not 1 gallon or 5 gallons. They're 5,000 gallons or 10,000 gallons, or, there are impoundments built that are lined that hold, hundreds of thousands of gallons. So I think I don't have I can't give you a good order of magnitude guess other than to say the quantities of materials involved are extremely large. The volumes of water being generated and the volumes of fluid being generated and the amounts of scale being generated are quite large.
Yeah. Thank you.
If I can interject one thing here, it seems like I'm doing my best to badmouth everybody, the oil industry, EPA, and so on. I have to, at the same time, acknowledge this. I'm living, it's about 6 degrees outside my house right now, and I'm living in a house that is absolutely uninhabitable without natural gas. And this is just one of those human dilemmas, and I don't have an answer for, and I don't think we as a society have a good answer for. If we came along and said, well, okay, we won't have any more oil and gas development, we won't use natural gas because it has all these problems, then suddenly, maybe 200 million Americans are living in houses that are uninhabitable in the winter. My house is not inhabitable unless I have a natural gas supply for my furnace when it's 6 degrees outside. So, there's many situations where there just is no answer. And I think this is one of those.
Since you brought it up, I'm just wondering what you think about like heat pumps and other forms of like hydroelectric, other forms of energy and for heating homes?
Well, I think every energy technology has its associated environmental costs, and those environmental costs are spread out over time and over different populations and places. I think heat pumps in general make more efficient use of the same quantities of energy. So it's probably more efficient to use an electric heat pump than to use, say, baseboard electric heating.
Right.
I think that no matter where you look, there is environmental damage. Nuclear power is not free of its problems, nor is hydroelectric power. Look at the environmental damage that's been created by something like Glen Canyon Dam or Lake Mead. I guess I don't really have an answer for that one other than we can look for things that are less bad.
Sure. I mean, I think that there's also, I mean, geothermal is a really interesting topic for me. I don't want to, segue out of our topic here. But PSR Pennsylvania is definitely interested in looking at that as a replacement for gas in our area, which might be more applicable in urban areas. So that's an option. But I guess I just wanted to push back a little bit. In such a cold area, of course, you can't live without heat, that's for sure. That you can't live without natural gas is not necessarily the truth, I think. I think that there are other ways and there's other systems and we have to move away from it. So I think that ultimately to say that we can't live without natural gas is a mistake. We can and we have to. We're not there yet. That's obvious. I have gas in my home too. I have a gas stove and I prefer not to, but it's expensive and it's complicated. But I think that is the direction that we're heading because we have to. There were some interesting comments I guess there's a couple more questions and there were lots of interesting comments popping up in the chat that I was trying to listen to you, Dr. Ketterer, and sort of seeing these come up on the screen. So AC, I don't know if you want to pick up on what people were throwing down there.
Yeah, thank you both. Thank you for bringing that up. It's definitely one of those human dilemmas that we're all dealing with. So one from Leatra, sorry if I'm saying your name wrong. I believe if it weren't for the oil and gas industry obstruction for profit and to ship overseas to higher price markets, we would have better options. And there would be no shell cracker plant, and maybe we would have to go without single-use plastic. We installed solar panels with geothermal, and then fossil fuel interests had the city penalize us because they want to own all the electrons. Our government needs to stop subsidizing this industry. Thank you for that. And then Laura says geothermal is not without risk for contamination for private wells, groundwater, and aquifers.
You'll probably be bringing more radon up to the surface of the earth with geothermal too.
Elaine said to me, heat pumps are a great option if it gets down to 5 or below. It gets down to 5 or below here in northern New Mexico. It works well. Yeah, there's a bunch of other comments, but I do want to have the last few questions that I had answered too. We have till 8, but yeah, we have a few more questions. So I'll go back to the Q&A list. So Patricia asks about PFAS in drinking water and filters. So she lives in Philadelphia and started using the zero water filters, which are expensive, but are supposed to remove all PFAS in drinking water. Do you know if this is true, or should I just go back to the cheap Brita filters? And I did see Tamala answered in the chat too.
I think this is an emerging area of concern. I mean, going back 4, 5, 6 years, PFAS weren't really on anybody's radar screen as from the standpoint of the drinking water industry and consumers of water. PFAS are quite difficult to remove from water. They are water soluble to begin with, and they're also fat soluble, which is leads to their bioaccumulation. But activated carbon is not fully successful. It's my understanding it's not fully successful in removing PFAS. There are a lot of technologies that are being developed. There's a company called Cyclopure that has made some type of a sorbent that's supposed to be very selective for PFAS. I don't really have any treatment method that I can recommend that I would hang my hat on and say this is going to solve your problem and go from 500 nanograms per liter down to less than 2. I don't have an answer for you on how one would do that, other than if you have the 500 nanograms per liter, you either need to remove it or find another water source.
Mhm. Right. I'm just going to drop that link to Cyclopure in the chat.
Cyclopure.
Yes. And Tamala from Move Plastics also agreed with you about the Brita filters not really doing it. And then she just said, taking off the carbon oxygen head, Dr. Ditchell, sodium hydroxide, the chemical in lye, decarboxylating PFCAs, one of the largest classes of PFAS compounds at low temperatures in dipolar aprotic solvents. Pollutants from gaseous or liquid solutions such as PFAS are absorbed by plant-based material and are broken down by microbial fungi.
I haven't read it, but it's my understanding. I heard the news, the press release on this study, evidently with using sodium hydroxide, and I believe the solvent is called dimethyl sulfoxide. By using sodium hydroxide in dimethyl sulfoxide at relatively low temperatures, you can destroy PFAS. That technology seems to be headed towards, disposing of unwanted product or waste, say, associated with the AFFF, the aqueous film forming foams for firefighting. It's a different story as to how would you remove it from, liters and liters of water where it's a few hundred nanograms per liter. But there's a lot of attention being paid to it. And I'll just add in one little aside. The Department of Energy has a lot of PFAS sites that has a lot of problems with PFAS at their sites, and they've shown very little interest in studying it until the national labs recently came along and went to Department of Energy and said, we have all these great ideas. We want to get a hold of all of this money that you're promising. And so between the DOE national labs and academia, private industry, there's a lot of brainstorming going on right now about how to do it. So I think in some time, with a few years time, we will probably have a much better idea on how to treat unwanted PFAS wastes, as well as how to remove it efficiently from drinking water.
Awesome. So then to follow up with that, Yvonne asks, and then where do the PFAS and the filter from the drinking water filters, where did the PFAS go from there?
Well, I think the average citizen would take their used filter and put it in the trash can, and it would go to the landfill. So then it goes to the landfill and it stays at the landfill, and sometime far in the future, it starts leaching out of the landfill and going back into the neighboring groundwater. So yeah, that is always a concern. When you take a pollutant and concentrate it, you've removed your problem from one place and you've just transferred the problem to a different medium.
Mhm. Yeah, great question. That's true. And then I saw that Tamala answered Amy in the chat with some labs, but do you have a favorite lab where you can send water samples to for general testing?
I'm not, I saw that comment in the chat, and I've heard of all of those laboratories. I would hesitate to make an endorsement for lack of familiarity with a lot of individual labs, but I think the answer is do your due diligence. If you submit some samples to a lab, develop some of your own quality control and submit those with the samples. Include some blanks, maybe include some salted samples, some known contaminated samples, and give your laboratory a chance to prove or disprove the veracity of its data. This company that I mentioned, Cyclopure, also uses their sorbent in a PFAS test kit. So I think it's $79 for one test kit, and they send you a device that looks like a funnel and has a membrane at the bottom of it, and you pour 250 milliliters of water through it, and then you mail it back to them, and they will do an analysis. They follow similar methods, but they have the disclaimer: we are not giving you, results that could be accepted by EPA as being enforcement or litigation quality. These are for information purposes. I think the answer is that city and county health departments need to become more involved in this. Once again, citizens have to take the ball in their own hands. Community level environmental monitoring is really necessary in many scenarios.
Mm-hmm. Absolutely. And yes, Tamala from Move Past Plastic knows her stuff. So definitely check out Move Past Plastic websites.
Mm-hmm.
Oh my gosh, I'm sorry. At this point, I'm like having trouble speaking. To follow up on that one, Patricia asks you and maybe anyone else who's in the group, what is the best present filter for PFAS in drinking water?
I can't really recommend one.
Okay. Maybe Tamala knows. And then I just had another private message question to me. We have 300 tons of TENORM dumped in a municipal landfill, and it's now showing up in the leachate that is sprayed for dust control. How do we get more monitoring and cleanup? There's 4 public schools in the area and dust blowing in the wind.
That sounds like a pretty egregious situation where this TENORM is being dumped. And this is, again, sort of a regulatory failing, a loophole. That type of material should not be disposed of recklessly anywhere near humans. How do you get some environmental monitoring done of that scenario? I think you have to try to make some contacts with people like myself who are analytical chemists. I get approached by community members all the time about, can you help us with this? Can you help us with that? And some things are within my expertise and others are not. But that is a situation where I think you need to have some kind of collection of airborne particulate matter, and then that needs to be analyzed by a laboratory such as Dr. Bhaskaran's laboratory to, look for radium or some of these other isotopes he mentioned. It would help a little bit to know about what the nature of the TENORM is. But these transport of fugitive dust questions, these situations exist at a lot of places. One example that I think is not being studied enough is the White Mesa Mill near Blanding, Utah. There's big piles of essentially uranium mill tailings that are exposed, and they're blown around and impacting the White Mesa Ute community there.
Looks like Yvonne just shared a resource in the chat too. And you mentioned it's okay for people to contact you. Should I put your email in the chat right now?
I will put an email in here right now.
Okay, very good. Thank you.
I can, try to give advice as best I can. I don't have the answer to everything, and I am quick to say when I don't know the answer. But anyone here is welcome to contact me, and I'll be happy to talk to them.
Excellent. And I think that about wraps it up for questions, and we did it just in the nick of time. So if folks want to just add any other comments into the chat now, or unmute and say some words of gratitude for Dr. Ketterer, and feel free.
Yeah, thank you so much, Dr. Ketterer. It was great having you. Thank you all for your attendance and for your very robust chat. Everybody was asking questions and talking to each other, so I thought that was really great. And anybody wants to jump off of mute, go right ahead and say what you've got to say. Thanks so much for being here.
I need someone to send me the chat.
Thank you.
Are
Thank
you
you
gonna
very much.
say the chat, AC Stubble? Yeah, okay, I put it in the chat, so please send it to me.
All right.
Okay, great. I would like to say that we will send the slides and the chat to anyone who registered.
Okay, perfect. So you'll get it, Jan.
And Dr. K, just another analytical chemist sitting here. Thank you so much for what you do. I would love to stay in contact.
Please feel free to write up. There's no such thing as not having enough friends and collaborators.
Okay. You are right, Amy. Halt the Harm rocks.
Please join us over on the network if you haven't already. It's I'll drop the link one more time right now. It's really an awesome place over there.
Well, thank you, everybody, for coming and for your engagement and excellent questions, and for putting up with me for all the hand waving and saying I don't have the answer to that one.
That's a good scientist. You know what you know, and you know what you don't know. That's honest.
100%.
Peace, John.
Nice seeing you, John, and Kay and Tamala. Thank you, everybody, for being here.
Yeah, and thank you, Trevor. Thank you for starting us off and giving us some visuals so we can sort of picture what in the world we're talking about when we're talking about such a complex topic. Really appreciate it. My camera's going crazy.
All right, well, that's a wrap. Thank you all, and enjoy your night. Bye.
Thank
Okay.
you.
Bye-bye.
All right, bye. Thank you.
I have